An industrial consumer has a daily load pattern of 2000 kilowatt, 0.8 power factor lagging for 12 hours, 1000 kilowatt for 12 hours. Then what about the load factor? We know very well load factor. Students, all of you try yourself. After that, check with my answer. What is the formula I have given? It is very easy to remember. Load factor always associated with load and it is less than 1. So average load is in the numerator, maximum load in the denominator. Average load in the sense number of units generated or number of units consumed for a specified time period by maximum load. Okay, so how many units generated? Here already kilowatt given, so no need to take the power factor. Okay, if they have given kVA, then we have to take the power factor. So 2000 kilowatts for 12 hours and 1000 kilowatts for 12 hours. So then total number of units generated are nothing but 2000 into 12 hours plus 1000 into 12 hours. This is the total units generated by time. Particular time means 12 plus 12, 24 hours. They have given daily now. We have to take 24 by maximum load. Here they have not mentioned, but we can get idea now. 2000, 1000. In this, which is the maximum 2000 now. So we can take 2000. If they have not given also, we can get the idea. Okay. Then what is the answer you are getting, guys? 12 to 3000 by 2, 1500. 1500 by 2000. 5 3s 5 4, 3 by 4, that is nothing but 75%, 0.75. So the answer is option C. I think you also got the same answer, 0.75. These are the very good practice questions, guys. Okay, so in the previous session I have given the formulas. If you have not watched, try to watch that one by click on the playlist. Okay, coming to the next one. And students, it is very difficult to get topic wise MCQs. You can get here. Okay, so if you want to do anything, you can please share to all your friends, then it will be helpful for the so many students. Okay, a generating station supplies the following loads: 15,000 kilowatt, 12,000, 8500, 6,450. The station has maximum demand of 22,000 kilowatt. Calculate the diversity factor. Calculate the diversity factor. We know very well diversity factor is equal to sum of maximum loads by maximum load of the system. Maximum load of system. Maximum load of the system. So sum of the loads is nothing but 15,000 plus 12,000 plus 8500 plus 6,000 plus 450 by here 22,000. Okay, so if you calculate, then what is the value you will get? 15 12 27 27 8 35 500 35 500 41 500 41 500 plus 450. So you will get 41 950. So 41 950 by 22,000. That means you will get approximately less than 2, that is 1.9. Okay, and one more thing, guys, a small trick is nothing but generally this diversity factor is always greater than 1. We have to eliminate the option which are less than 1. So we can eliminate these three now. So we can directly give the answer as option A without calculation. But If they have given all are more than one, then we have to calculate only. So that's why I am giving both the methods. Okay. In the previous also, they are asking the load factor. They are asking the load factor. So load factor is always less than 1. So more than 1 is cancelled. 1.5 is cancelled. And it is not this much of less. So we can go for the option C directly. Okay. But better to calculate and give the answer. Coming to the next one. The connected load of a consumer is 2 kilowatt and maximum demand is 1.5 kilowatt. The demand factor of the consumer is dash. Demand factor, very, very important. Demand factor is equal to, we know, maximum demand by connected load. By connected load. So what is the maximum demand here? 1.5 kilowatt. Connected load is 2 kilowatt. So that is nothing but you can say 0.75. Okay, 0.75. That means it is also less than 1. It is also less than 1. So the answer is option C. Coming to the next one. The knowledge of diversity factor helps in computing dash. Diversity factor is equal to sum of maximum loads by maximum load of system. Okay, so that means if you know the diversity factor, you can find out the maximum load of the system or maximum demand of the system. And we know very well, as the diversity factor is high, then maximum load or maximum demand is less. Then we can go for installed capacity is less. Then fixed cost is reduces. Fixed cost is reduces. We have already discussed this. Okay. So here helps in computing maximum demand. Coming to the next one. The diversity factor of the system is high, which cost of the system reduces. Just now I have given as diversity factor is more, maximum demand is less. As the maximum demand is less, then installed capacity is less, then fixed cost is less. Fixed cost is less. Okay, so reduces the fixed cost. Answer is option C. Coming to the next one. If the load factor of the system is high, which cost of the system is reduced? This one also we have discussed now. Load factor is equal to average load by maximum load. So as the load factor is high, it generates more units. Average load is more units generated. More units are generated or more units are consumed means operating cost is less. Operating cost is less. For the same operating cost, if you generate more units means that is advantage. So operating cost is less. So running cost or operating cost and fixed and initial both are same. Okay, coming to the next one. In a system, if the base load is same as the maximum demand, the load factor will be dash. The load factor will be dash. We know very well the load factor formula, average load by maximum. Okay, and we know very well this average load is equal to, average load is nothing but can say base load. Base load. So both are same means you will get 1. So the answer is option 1. Answer is option 1. Coming to the next one. The daily energy produced in a thermal power station is 720 megawatt hour at a load factor of 0.6. What is the maximum demand of the system? What is the maximum demand of the station? So same formula guys, nothing in this. Come on, calculate load factor. They have given is equal to average load by maximum load. So load factor 0.6. What is the average load daily? And the energy generated is nothing but 720 megawatt hour by that daily means number of hours are 24 by maximum load. 24 ones, 24 threes, 0. 30 you will get. So maximum load is equal to 30 by 0.6, 300 by 6, 50. So the answer is option A, 50. So the answer is option A, 50. Okay. Coming to the next question, guys. The maximum demand of a consumer is 2 kilowatt and the corresponding daily energy consumption is 30 units. What is the corresponding load factor? What is the corresponding load factor? So we know very well load factor. So how many times we have done average load by maximum load. Okay. So average load, number of units consumed by daily daily means 24 by maximum load 2 kilowatt. So 30 by 48, 5 by 8. So 5 by 8 means 62.5. So the answer is option 62.5. So the answer is option. Okay. Okay, students, we will discuss the remaining in the next session. If you have not watched the previous, click on the playlist and you can find out the previous. And if you want to download this topic-wise MCQs, you can visit the sunnilengineeringacademy.com. In this, you can also get other electrical subject, the handwritten notes, and also the MCQs like this topic-wise MCQs. Okay, so just open sunnilengineeringacademy.com. Okay, in this under SSC, JE and state AE examinations, you can find out electrical PDF. If you click on the PDF and you after that, for example, power systems notes. If you want power systems notes, you can click on add to cart. And if you want power systems MCQs, 300 MCQs, you can add to the cart. Okay, and then after that go to the cart and check out. Okay, and log in with your credentials. After that, after completion of the successful thing, then you have to click on my account and then click on downloads. Then you can find out your PDF. So click on my orders downloads. Then you can get your PDF notes and you can download. Okay, and you can